Let's look at our final abiotic site factor, topography, and see how it influences tree species composition and growth. Topography describes the relief features of an area. Two components of topography are slope steepness and aspect, which together influence tree species composition and site productivity or growth. Let's begin with slope, or how steep the ground is. Some topography is flat, some rolling, and some steep. How steep a slope is impacts site productivity. This chart shows slope steepness on the horizontal axis, with amounts of erosion and runoff depicted in blue, and soil depth and productivity depicted in orange on the vertical axis. Looking at the blue line, we see that flatter terrain experiences less water runoff and soil erosion. As steepness increases, so does erosion and runoff. Depicted by the orange line, we see that less steep slopes have deeper soils and higher productivity. Soil depth and productivity decrease as slope steepness increases. On most forest sites, soil builds up over time as organic matter, like leaves, decomposes. On steep slopes, however, soil loss from erosion may actually occur at a faster rate than soil is forming. For site productivity to increase, the rate of soil formation must exceed the rate of soil loss from erosion over time. Soil depth also varies over the length of a slope. Soils are generally deeper at the bottom of a slope and shallower at the top. Over time, upper slopes experience more soil loss from erosion and therefore have shallower soils than areas downslope where soil accumulates. This relationship of slope steepness to erosion and soil depth is evident in the Appalachian Mountains, a very old mountain chain. A tremendous amount of erosion has occurred over the course of millions of years, moving soil down slope. Soil has accumulated on the lower slopes and in the valley bottoms. There is a direct correlation between soil depth and tree height. In general, deeper soils have better water and nutrient holding capacity and thus greater productivity. As a result, trees grow taller in deeper soils found on lower slopes and in creek bottoms. Slope shape also influences tree height growth. As a slope undulates, its shape may be either concave, sloping inward like a bowl, or convex, sloping outward. Like lower slopes, concave-shaped slopes experience less erosion, hold more moisture and nutrients, and tend to accumulate soil. Trees will grow taller here. Convex-shaped slopes, on the other hand, tend to be droughtier sites with higher rates of soil erosion and water and nutrient loss. Therefore, trees growing on convex-shaped slopes tend to grow shorter. So, even though a tree is positioned higher upslope, if it's growing in deeper soil found in a concave-shaped slope, it may have the ability to grow taller than a tree on a convex-shaped slope further downhill. Now that we've discussed slope, let's examine aspect, the other component of topography that influences tree species composition and site productivity or growth. Aspect is the compass direction a slope faces. The direction a slope faces influences the amount of sunlight, heat, and wind a site receives. These in turn influence the species of trees able to grow on a site and how well they grow. Here in Pennsylvania and elsewhere in the northern hemisphere, the sun is always in the southern sky. It rises in the east and sets in the west. This diagram shows 4 solar insolation curves for the northeastern U.S. Solar insolation is the amount of solar radiation striking the Earth's surface. Each curve represents a slope facing a specific compass direction or aspect, north, south, east, and west. Curve height represents the amount of solar insolation. The time of day is labeled across the bottom. Let's begin with the green curve representing an east-facing slope. East-facing slopes get the highest amount of solar insolation during the morning. The opposite is true for west-facing slopes shown in purple. They get the most solar insolation in the afternoon. The solar insolation on a south-facing slope is most intense during the middle of the day, as represented by the red curve. The blue curve represents a slope with a north-facing aspect. Its solar insolation is spread out over the day and less intense than a south-facing slope. Although solar insolation is not as intense for north-facing slopes, the amount of light received is relatively higher across the length of the day. South-facing slopes receive the most intense sunlight. Based on aspect alone, they have the hottest and driest growing conditions. These sites tend to be less productive and are generally composed of trees that are adapted to drier growing conditions. Slopes facing to the north receive the least direct sunlight and are typically cooler, moister sites. This creates a superior growing environment where trees are able to obtain their best height growth. North-facing slopes can be some of the most productive growing sites. And east-facing slopes receives sun during the morning when air temperatures are typically lower. Therefore, east-facing slopes lose less water to evaporation and are less likely to experience moisture stress, unlike west and south-facing slopes. East-facing slopes can be fairly productive growing sites. Later in the day, when daytime temperatures are at their maximum, the sun has moved around towards west-facing slopes. The added heat causes the water to evaporate from these sites, making west-facing slopes hot and dry. On these sites, water stress decreases productivity and causes reduced tree growth. This graphic depicts the relationship between aspect and tree height. Can you guess which tree represents north, south, east, and west-facing aspects? Which aspects provide the harshest growing conditions? Slopes facing to the south and west are hotter and drier. In general, trees are shorter on these slopes. Slopes facing to the north and east are moister, cooler sites. This creates a better growing environment. Therefore, trees are able to grow taller. The ability to read the landscape is part of developing your understanding of forest ecology. This image summarizes the influences of topography as an abiotic site factor. Notice how the sun strikes some parts of the landscape while other areas are shaded, defining their aspect. Can you pick out areas where the soil would be deeper or shallower? With some practice, you can begin to interpret how aspect, slope position, and steepness come together to influence tree species composition and site productivity or growth. That concludes our discussion of topography, the final non-living or abiotic site factor in the ABCs of forest ecology.